Welcome back to TechTide Digital Lifestyle, your destination for professional marine and industrial electrical engineering tutorials. This is tutorial lecture series 2 in our Alternator Masterclass, and in this session we will focus completely on the physical construction of an alternator. Understanding construction is extremely important for ETOS and marine engineers because most operational problems, such as overheating, abnormal vibration, insulation failure, and voltage instability, are directly related to internal components. In this lecture we will examine the stator, rotor, bearings, air gap, cooling system, insulation arrangements, excitation components, terminal box, and mounting frame. These topics are very commonly asked in oral examinations and technical interviews, so pay close attention to how each part is built and what function it performs in real shipboard installations. Before start lecture, please like and subscribe my YouTube channel TechTide Digital Lifestyle. Stator core or windings. The stator is the stationary outer part of the alternator and is responsible for producing the output electrical power. It is constructed from thin laminations of silicon steel which are insulated from each other to minimize eddy current losses and heating. Slots are cut along the inner periphery of the stator core, and inside these slots the three-phase distributed windings are placed according to the electrical design. These windings may be connected in star or delta depending on voltage requirements. Ventilation ducts are formed between laminations so cooling air can circulate through the machine. From an exam perspective, always remember that the stator is where voltage is induced, and lamination is used specifically to reduce losses in temperature rise. Types. The rotor is the rotating part of the alternator and carries the DC field winding which produces the magnetic flux necessary for voltage generation. Two main rotor designs are used in practice: salient-pole rotors and cylindrical, or non-salient, rotors. Salient-pole rotors have projecting poles with pole shoes and are normally used in low-speed diesel-driven generators, which is typical for marine installations. Cylindrical rotors have a smooth forged steel body with slots for field coils and are used in high-speed turbo alternators. Damper bars are embedded in pole faces to improve stability and reduce hunting during sudden load changes and synchronization operations. Shaft, bearings or air gap. The rotor is mounted on a strong steel shaft which transmits mechanical power from the prime mover into the alternator. Bearings support this shaft and allow smooth rotation. These may be ball bearings, roller bearings, or sleeve bearings with pressurized lubrication systems in larger machines. Proper alignment and lubrication are critical on board ships because vibration and hull movement can accelerate bearing wear. Between the rotor and stator exists a small and carefully controlled air gap which strongly affects magnetic flux, voltage regulation, and vibration behavior. An uneven air gap can lead to noise, heating, rotor rub, and even serious mechanical damage. Cooling systems. Cooling is a vital part of alternator construction because heat is produced by copper losses, iron losses, and mechanical friction. Smaller machines rely on shaft-mounted fans for self-ventilation, while larger marine alternators use forced air systems with ducting and air-to-water heat exchangers connected to ship cooling circuits. The airflow path is carefully designed to pass over stator windings, rotor surfaces, and bearings before leaving the enclosure. Temperature sensors such as RTDS and thermistors are embedded inside windings and bearing housings to provide alarms and trips through the power management system if overheating occurs. Insulation system. The insulation system prevents short circuits between turns, between phases, and between windings and earth, making it one of the most critical factors affecting alternator reliability. Each conductor has turn insulation, slot liners separate windings from the stator core, and the completed winding is impregnated with varnish or epoxy resin to increase mechanical strength and moisture resistance. Insulation classes such as Class F and Class H specify the maximum permissible operating temperature. In marine environments where humidity and salt contamination are present, good insulation protection and regular insulation resistance testing are absolutely essential to avoid earth faults and catastrophic winding failures. Excitation system. To establish magnetic flux, DC current must flow in the rotor field winding, and this is supplied by the excitation system. Older designs used slip rings and carbon brushes, but most modern marine alternators employ brushless excitation consisting of a small AC exciter mounted on the shaft, a rotating diode rectifier, and often a permanent magnet generator or PMG. The AVR controls the exciter output and therefore the main field current, keeping terminal voltage constant during load variations. Brushless systems greatly reduce maintenance and eliminate sparking, which is particularly important in enclosed engine room environments. Terminal box or connections. The terminal box contains the stator output leads and the connection links for star or delta configurations. It also houses the neutral bar and mounting arrangements for current transformers and potential transformers used for protection relays and metering. Proper earthing of both the alternator frame and neutral point is essential for safety and earth fault detection. Heavy-duty cable glands and sealing arrangements protect against moisture ingress. Engineers must regularly inspect terminal boxes for loose connections, discoloration due to overheating, and signs of insulation breakdown. Frame or mounting. All components of the alternator are housed within a rigid steel frame which ensures mechanical strength and precise alignment. The enclosure carries an IP rating that indicates protection against dust and water ingress. Marine generator sets are installed on anti-vibration mounts and secured with foundation bolts to reduce transmission of vibration to the hull. Access covers allow inspection of bearings, windings, and cooling passages. Classification Society rules require specific construction standards, corrosion protection, and safety clearances for shipboard. To summarize alternator construction, the stator produces output voltage, the rotor creates magnetic flux, bearings and shaft allow smooth rotation, cooling systems remove heat, insulation ensures reliability, and the terminal box safely delivers power to the switchboard. For examinations, you must be able to draw labeled diagrams and explain rotor types, cooling methods, insulation classes, and excitation systems clearly. If this lecture helped you, please like the video, subscribe to TechTide Digital Lifestyle, and turn on notifications so you don't miss the next part of this masterclass. Comment below if you are an E2 candidate, marine engineer, student, or industrial professional and tell us where you are watching from. I'll see you in the next lecture where we cover the working principle and EMF equation of alternators. Thanks you for watching.